we're going to do the warm up together today. I had you do it on your own yesterday. We're going to go ahead and work on this together today. And all three of these, we're going to use FOIL. First, outer, inner, last. So first times first on this first one, x times x is x squared. The outer would be x times -4, so minus 4x. The inner would be 4 times x, which would be plus 4x. And then the last would be 4 times -4, which is -16. And if we put those together, the two terms in the middle cancel each other out, the -4x and the positive 4x, and we end up with x squared minus 16. So that's it for the first warm-up problem. For the next one, same idea. First times first, 5m times 5m. That would be 25m squared. The outer terms, 5n times -1 would be minus 5m. The inner terms, 1 times 5m is plus 5m. And then the last ones, 1 times -1 is -1 or minus 1. And once again, the two terms in the middle, -5 and positive 5m, those cancel out, and we're left with 25m squared minus 1. And for the third one, we've got 2a times 2a. So first times first, 2a times 2a, that's 4a squared. The outer terms, 2a times -3b would be a minus 6ab. The inner terms, 3b times 2a would be plus 6ab. And then 3b times -3b would be a minus 9b squared. And once again, -6ab plus 6ab, those cancel out, leaving us with 4a squared minus 9b squared. So the results of these binomial times binomial, we've seen ones like this before from last week when we learned FOIL. These are known as a difference of squares. Does anybody think they know why it's called a difference of squares? Take a look at the answer and see if you can maybe work out why would this be called a difference of squares? What does difference mean? Math-wise. Subtraction. Okay, so all three of them have subtraction, so that's the difference part. Squares. What do we think about that? What is a square in terms of not a shape, obviously, but like as a number? If you square a number, what does that mean? Power of 2 multiplied by itself. Yeah. So x squared is x times x minus 16, which is 4 times 4, with subtraction in the middle. So it's a difference of two values that have been squared or taken to the second power. 25m squared is the product of 5m times 5m. Same thing multiplied by itself. 1 times 1 is 1. 4a squared, that's 2a times 2a. Same thing multiplied by itself. And then 3b times 3b gives us 9b squared. So two things end up being perfect squares, meaning you can multiply the same thing by itself to equal the two terms that are there, and there's a subtraction in the middle. That gives us a difference of squares. And so today we're going to be factoring these. And actually, I think a lot of what we do today is going to be quicker than what we did yesterday even. So this is a different method of factoring than what we saw yesterday. Yesterday, we factored out a greatest common factor in order to factor the polynomial. Today, we are going to be identifying a difference of squares. And so it says steps to factor a difference of squares. First, make sure you have an actual difference of squares. It must be a subtraction sign in the middle. You have to have subtraction in the middle. Otherwise, it's not a difference. And you are able to square root both terms that are there. Use the following rule to factor. It says a squared minus b squared. So this is kind of our generic algebra example. It is going to be a plus b times a minus b. And so if you look back at the original three problems in our warm-up, there were only two different terms between the two sets of binomials. Like on number 1, we had x and 4, and then another x and another 4. And one of them had a plus, one of them had a minus. Same thing with problem number 2. 5m and 1, 5m and 1. One of them was a plus, one of them was a minus. Same thing with the third one. 2a, 3b, 2a, 3b, plus and minus. And so when you factor it, you go from the difference of squares and you factor it out to two binomials. It's basically going from the simplified version back to the product of two binomials. And then it says to check your work by distributing. Again, this is something that you can do. It is something that if you are unsure of your answer, I would recommend it. But if you feel confident in what's going on, then you can just write your answer. So let's jump right in. Factor each difference of squares. Check your work by distributing. If a polynomial cannot be factored, just like yesterday, if it can't be factored at all, you got to write prime. So on problem number 1, all we're doing is looking for something that multiplies by itself to equal a squared and something that multiplies by itself to equal 4. So what multiplies by itself to equal a squared? A times a, exactly. So we're going to set up two sets of parentheses. And the first term in each set is going to be a. And we're just following this guide right here from step 2. We've got our, literally this one is a and a, just like the example up here. And then we're going to have a plus in one of them and a minus in the other. And then what number multiplies by itself to equal 4? 2. So a plus 2, a minus 2. And that's our answer. And the reason why we can factor it like this and we can't factor it like what we did yesterday, if we would have seen a problem like this yesterday, we probably would have written prime. Because there is no common factor between a squared and -4 or a squared and 4. You can't divide something out of both of those. So there's no GCF going on here at all. And so yesterday we would have written prime for this, but we're finding out today that you can factor this. It's just a different method of factoring. So problem number 2 then. What do we think about that one? Any thoughts on what this will factor to as a difference of squares? N plus 8 and n minus 8. Good. So n squared is n times n. 64 is 8 times 8, so we get n plus 8 and n minus 8. All right. How about the third one? What number multiplies by itself to equal 81? 9. Okay, so we're going to have 9 and 9, and then plus and minus. What's the second term? X. Yeah, 9 plus x, 9 minus x. Number 4, how about that one? C plus 10, C minus 10. Good. So what I'd like for you to try is work on 5 through 12 real quick. See if you can get those factored. All of them will factor. None of the ones on this first page are prime. So take a couple minutes, work on 5 through 12, and in a couple minutes we'll check back in. And if you have questions as you're working through these, let me know. And in a couple minutes, I am going to be calling on some folks randomly. So be prepared to have an answer. We'll do, let's say, another 2.5 minutes. 8:22, we'll check in on these answers. All right. So let's see, number 5. Let's see, Tanner, do you have anything for number 5? Oh, shoot, you know what? I said there were no prime ones. I lied. 5 is actually prime. Sorry. 5 is prime. I misled you. I apologize. Why is 5 prime? Anybody can tell me that? Tell me what do you think? Yeah, it's a plus. It's not a minus. This is a sum of squares, and so that actually doesn't work. If you were to do, and I'll show you real quick why. If you were to do k plus 5 and k minus 5, which if you wrote that down, no worries. I'm sure plenty of people wrote that down for the answer on that one. If you were to use FOIL on this and distribute this back out, which is why it says check by distributing, but in order for it to be a difference of squares, you have to have a minus with the terms. This would be k squared minus 5k plus 5k minus 25. And then the 2 in the middle would cancel out, giving you k squared minus 25, which does not match with k squared plus 25. So 5 is prime. There is no such thing. I mean, yes, this is a sum of squares, but you can't factor it. There is a such thing as a sum of squares. It's just not factorable, so that would be prime. All right. So sorry about that, Tanner. Let's give you number 6 instead. Yeah. So and that's actually just going to be 1 plus 7y and then 1 minus 7y. So to undo the squared with the y, it's just it'll drop the 2 for inside the parentheses. So nice job. So 1 plus 7y, 1 minus 7y. That's it for number 6. Number 7, that is going to be, let's see, Sila, can you help me out with number 7? What number multiplies by itself to equal 9? So 3, all right. What multiplies by itself to equal b squared? So let's see. Sila, I'll go ahead and ask you this one too. What multiplies by itself to equal b squared? Or what multiplies by itself to equal 100? How about that one? B. So b times b is b squared. What number times itself equals 100? How about that? Lou, can you help out? What number times itself equals 100? There you go. So 3b plus 10, 3b minus 10. All right. Let's see. Jane's not here. How about 7? Angel, what do you have for number 8? Number 8. All right, let's take a look at it then. What number times itself equals 25? All right. And then what times itself equals x squared? All right, so 5x, plus, minus, and there you go. 5x plus 7, 5x minus 7. Number 8, we just did number 8, sorry. This is person who has number 8. So problem number 9, Saul, what do you have for number 9? Yeah, 4A? 4A? Okay, so for number 9, let's go with 4A, because 4 times 4 would be the 16. So 4A, and then I like the 11, plus 11, and then 4A minus 11. Awesome, nice job. Next, let's see. Lou, help me out with number 10.
So
It actually is. Let's do the x first, though. We'll come back to the 81. So what times itself equals x squared? Yeah. So x, and then we're gonna have a plus and a minus. And then what can you multiply together to equal 81?
9.
There you go. So we're gonna have x plus 9y and then x minus 9y. Good, nice. Sweet. All right, next one. Let's see, already went. Jaime, help me out with number 11. What number times itself equals 4? What number multiply? Yeah, 2. All right. And then what times itself equals h squared? So it's just going to be h by itself. So anytime you have something, a squared variable, the thing that multiplies by itself to equal a squared variable is just one of that variable. So 2h. And then we're going to have a plus, we're going to have a minus. And then what times itself equals 25? 5. All right. And then what times itself equals g squared? G. There you go. So that's our answer. 2h plus 5g times 2h minus 5g. All right, last one from the first page here. Let's see, Justin's not here today. Elena, number 12. 8u plus v and 8u minus v. Good. So 8u plus v, 8u minus v. Great. So that's it for the first page. Yeah, go for it. All right, let's have a look at page 2 then. Any questions so far? Hopefully this process starts to feel a bit repetitive because all you're trying to do is figure out, all right, what can I multiply by itself to equal the first term? What can I multiply by itself to equal the second term? I'm going to set up 2 sets of parentheses. One's going to have a plus, one's going to have a minus. So number 13, x squared y squared. What would multiply by itself to equal x squared y squared? What would multiply by itself to equal x squared y squared? Any ideas on that one? All right, what multiplies by itself to equal x squared? What multiplies by itself to equal x squared? All right, what multiplies by itself to equal y squared? So the thing that multiplies by itself to equal x squared y squared would be xy. So we got xy plus and xy minus. What's the number that we put in here on the end? 1. Yeah, plus 1 minus 1. 1 times 1 is 1. Good. Number 14. 81n to the 4th minus 25. So what would multiply by itself to equal 81n to the 4th? So yeah, it's gonna be 9n squared. Nice. So 9n squared plus 5, and then 9n squared minus 5. Excellent. Number 15. Thoughts on that one? Anybody have any ideas on number 15? Finding any issues with 15? Where? Yeah, the 5 kind of messes things up. The thing that multiplies by itself to equal 5, not so much. So what do you think? No, actually, this one's not factorable. So this is going to be prime because 4 is a perfect squared, c squared is a perfect square, d squared is a perfect square, 5 is not. And so if you don't have a perfect square, we can't use the difference of squares. So 15 prime. 16, though, is going to be 7m squared plus 4 times 7m squared minus 4. What do we think about 17? We got 16. 17 says k to the 6th minus 16. What do we think about that one? What times itself equals k to the 6th power? Think about our exponent rules real quick. What do you do with exponents when you multiply variables? You add them, okay. So what multiplies by itself to equal k to the 6th then? K to the 3rd, good. We are not square rooting the exponent. You only square root the actual number. With the exponent, you cut it in half. Because when you multiply variables, you add the exponents together. K to the 3rd times k to the 3rd is k to the 6th power because we're adding the exponents. And so we're going to get k to the 3rd plus 4 and k to the 3rd minus 4 for number 17. All right, the last 3 here before we move on to the final examples. This will be 2p squared plus 5 times 2p squared minus 5. And then number 19 will be 11r to the 3rd plus 1 times 11r to the 3rd minus 1. And then 20, we'll have 8m squared plus 3n times 8m squared minus 3n. So hopefully those at this point aren't feeling too crazy. As long as it's minus and as long as things can be square rooted, it's going to be a difference of squares. Now we're going to move on to 21 through 32 real quick. And you might notice that these pretty much look like difference of squares. However, none of the numbers are actually perfect squares at this point. And so the directions say to look at for a GCF first. So we are combining what we did yesterday with what we learned today. So look for a GCF first, then factor the remaining difference of squares. So on number 21, is there a number that we can divide out of both of those? Can we divide those two numbers by anything here? 2 and 72? Yeah, by 2. So if we divide these both by 2, we'll start with that. We need to leave a little bit of room. We're going to have 2 times n squared minus 36. 72 divided by 2 is 36. Now, if you look here, is this a difference of squares? Can you multiply something by itself to equal 36? Yeah, So this will be 2, and then n plus 6 times n minus 6. That'll be our answer for number 21. How about number 22? Is there a number that we can divide 18 and 50 by? Or what's the largest number we can divide 18 and 50 by? You would think it should be bigger than 2, but it's not. It's just 2. So 18 and 50, the greatest common factor between 18 and 50 is just 2. So we'll divide those both by 2. And that'll be 2 times 9x squared minus 25. So when we factor out our 2, we've got 9x squared minus 25. Are both 9 and 25 perfect squares? Yeah, 9 is 3 times 3, 25 is 5 times 5. So we're going to get 2 times 3x plus 5 times 3x minus 5. All right. Let's keep going here. How about 23? What is the largest number we can divide 32 and 18 by? Again, you'd think it should be more than 2 because of the types of numbers these are, but it's not. It's just 2 again. So divide out of 2. So that'll be 2 times 16s squared minus 9u squared. 16 and 9, those are both perfect square values. So we're going to get 2 times 4s plus 3u times 4s minus 3u. All right, let's skip ahead to number 26. So skip 24, skip 25. Let's go to 26 real quick. And 26 is 100 b to the third minus 36b. Now, just because, this is where it gets a little weird. Just because these two numbers are perfect squares, which they are, 10 times 10, 6 times 6, doesn't mean that we can't still factor out a number first. Not only that, this will be our first example where we can factor out both a number and a variable first. So 136, what can those both be divided by? What's the largest number those are both divisible by? Any thoughts on that? 36 and 100. This one is more than 2. Common factor of 136, 4, yeah. And then they also both have b that we can factor out of it. So our GCF this time is 4b. So we're going to factor out a 4b to start with on this one. So that'll be 4b, which will give us 25b squared minus 9. So even though we started with a difference of squares, when we divide both of them by 4, we still have a difference of squares. And so there's a difference between factoring and factoring completely. So we could have just factored this as a difference of squares and gotten, well, we would have had to factor out b first, but it would have been 10b plus 6 and 10b minus 6. But that's not factored completely. Factoring completely means you factor out as much as you possibly can, and which is what we're doing here for 4b. So then we're going to get 4b, and that'll be 5b plus 3 and 5b minus 3 for our difference of squares. Okay, let's go to number, let's do 28 because we got a couple of different variables here on 28. Skip 27, go to 28. What number can we divide 8 and 32 by? Biggest number we can divide 8 and 32 by. 4 works, but there is one larger. 8, yeah. So we'll divide both by 8. What about variable wise? Is there a common variable that we can divide out of both of them? Y, yep. So 8y is our GCF. So this would be 8y, and then in parentheses, the 8s and the y's cancel out, so we're just gonna have x squared here. And 32 divided by 8, that'll be -4, and then y to the third divided by y would be y squared. So we've got 8y times x squared minus 4y squared. And in the parentheses, we have a difference of squares. So we're gonna have 8y times x plus 2y times x minus 2y. All right, we're gonna do 30 and 32, and then we'll be done. So number 30. 3n squared minus 147. The only option here is what for factoring out? It's got to be 3, right? Does it work? Is 147 divisible by 3? Hopefully. Yeah, what does it equal? 147 divided by 3. What do we get? What is it? I think it's a little more than that. 49, yeah. So that'll be 3 and then n squared minus 49, which is a difference of squares here. So that'll be 3 times n plus 7 times n minus 7. That's our answer for number 30. And then the last one, 32. The last one that we'll do, we'll skip 31, go to 32. Can we factor everything out of those two terms first? What do you think? M to the third n minus mn. Anything we can factor out of those two terms? Do they both have at least one m? Yeah, do they both have at least one n? Yeah. So our common factor here, GCF, is mn. So if we factor out an mn from the first term, so mn, that'll be m squared, and that's it, because the n's cancel out. And then it's going to be minus what? Minus 1, good. M's and n's cancel out, meaning we've got m squared minus 1, which is a difference of squares. So that'll be mn times m plus 1 times m minus 1. Okay, and that is it. So, done with today's notes.